I am Ariel, and today I will be talking about particle physics. Particle physics is a study of the subatomic world. By studying the laws of physics on a small scale, we can better understand the origins and workings of the universe. You and everything around you is made up of atoms. An atom has a nucleus with protons and neutrons and is surrounded by shells of electrons. But what are protons, neutrons, and electrons made of? Protons and neutrons are made of more fundamental particles called quarks. Electrons are, well, just electrons. The standard model is like the periodic table of elements, but instead of elements, the chart involves a zoo of particles. The standard model is incomplete and doesn't explain everything like dark matter or gravity. In the quark family, there are 6 quarks. The up and down quark are responsible for much of the universe because they group together to form protons and neutrons. A proton is made up of 2 up and 1 down quark. A grouping of quarks is called a hadron. Each quark has properties like mass and electric charge. An up quark has a charge of positive 2/3, and a down quark has a charge of negative 1/3. If you add up the charges for the quarks inside a proton, you get positive 1. This is why a proton has a charge of positive 1. Isn't that neat? But what about the electrons in an atom? Well, electrons are already a fundamental particle and come from the lepton family. In the lepton family, there are 6 fundamental particles. Unlike quarks, leptons do not come in groups. Rather, they are alone. Neutrinos are a very light particle that is practically undetectable like a ghost. Billions of neutrinos emitted by the sun pass through you every second, but don't worry, the neutrinos won't hurt you. Another family in the standard model are the gauge bosons. Gauge bosons are force carriers for the 4 fundamental forces: the weak, electromagnetic, and strong force. The 4th fundamental force is gravity, but it doesn't yet fit into the standard model. The weak force is responsible for radioactive decay and is stronger than gravity because gravity is insignificant on subatomic scales. The next strongest force is the electromagnetic force. It is responsible for the attraction between a positive and negative particle and responsible for the repulsion between 2 positive particles or 2 negative particles. The last force is the strong force. If the electromagnetic force causes 2 positive charges to repel, how are multiple protons held together in the nucleus of an atom? Because the strong force is stronger than the electromagnetic force, it binds protons in the nucleus of atoms and binds quarks inside of hadrons. Last, there is the Higgs boson. The Higgs was theorized in the 1960s because the standard model didn't explain how certain particles got their mass. The Higgs gives particles their mass, and without it, atoms wouldn't form and life would not be possible. But we couldn't prove the existence of the Higgs boson until nearly 50 years later, when we completed the construction of the largest experiment in the world, a particle accelerator called the Large Hadron Collider, or LHC. The LHC collides protons together in a 17-mile ring at 99.99% the speed of light. By colliding particles at very high energies, the LHC can discover new particles and test theories. After 30 years of construction, the LHC started collecting data in 2009. In 2012, we proved the existence of the Higgs and determined its mass. Who knows what we will learn next about our universe from particle physics?